Relations and functions, this is day 1. So I'm going to cover part of 2.1 today. I'm going to cover the rest of 2.1 on Monday. Okay? And then, like I said, Tuesday we'll put it all together so you can practice all of it. We're going to go over a lot of terminology today so we can get ourselves all on the same page, speaking the same language, because there's some constructs that we have to follow when we do some of this stuff. Okay? First thing, a relation is any set of ordered pairs or points. And here is an example. Okay? 3, 2, that's 1 point. Negative 4, 7. 2, 11. Negative 4, negative 9. 1, 0. This is an example of a relation. This is a set of ordered pairs, a set of points. Grouping them together makes it turn into a relation. Every relation has a domain and a range, and you may have some familiarity with these terms. Maybe you've dealt with domain and range before. We're going to talk about them a little more in depthly today, and I'm going to be specific on how I want you to write the domain and range. Definition of domain. A domain, the domain of a relation is the set of all x coordinates. So we're going to separate out the x's from the y's. I'm guessing you can figure out what the next sentence is going to be, and you can change it. So use your copy and paste, change the words appropriately to see if you can figure out what the next sentence is actually going to be. Okay, what's the next sentence going to say?
The range of a relation is a set of all y.
Very good, class. Very good. All right. Now, how many had that figured out, that that's what the next sentence was going to be? Good. Okay. So here's the thing. Okay, the domain is all the x's, the range is all the y's. If you can't keep it straight, here's how I used to do it. I have it straight now, but the D comes before R, domain comes before range, X comes before Y, so it sort of lines up alphabetically that way. The first one that comes alphabetically is the domain, and the first one that comes alphabetically are the X's over the Y's. That's how I used to keep it straight when I had trouble keeping it straight. So if that works for you, go for it. Or if you have another mechanism that works, use that. Now the next thing that we're going to go over is really important. Because when you write out the domain and you write out the range, you have to do it in a very specific way. And so the next two things that I'm going to put up here are those specific ways that you need to write it down. So here they are. Two things. When you write them, you have to write it from smallest to biggest. You have to put them in order, from smallest to biggest in set notation. I'm going to show you set notation here in a second. And then you only ever write the numbers down one time. Even if they appear 2 or 3 times, you only write them down once. And we're going to write the domain and range for that relation at the top of the screen. And I'll walk you through that so we can get it correct. Are you dying? I mean, we're all kind of. Are you really have to go? You don't have any water with you? You're gonna miss this. You're gonna miss this. It's up to you. I mean, if you think you can't make class. So here's how we write this. Okay, we use what's called set notation. Okay, and let me show you what set notation looks like. First off, for the domain, we write the word domain. And you put in equals, okay? Write the word domain, put an equal sign, all right? Then we use the braces. And you guys, when we talk about braces, when you guys think about braces, you think about the squiggly parentheses, okay? So when we do that, it should look like that. So I put my left brace. You're going to have to practice it and get good at it. Or you can pull your keyboard up because your keyboard has it. Okay? Now, what we're going to do for the domain is look at all the x values. So we're going to look at all these x values. Okay? I'm going to write them down only once, regardless of how many times they appear. And we're going to put them in order from smallest to biggest. So of the numbers that I highlighted, what is the smallest number? -4. Okay? Then I put a comma. What's the next? There's 2 of them, right? Do I write both of them down?
No.
Only 1. Okay. What's the next number?
1.
1. Then what?
2.
2. Then what?
3.
Close the brace, and that is how you write domain. Okay. So now I want you to do that for the range.
Okay.
So here's what you should have had. Okay. The domain. There's the range. Okay. Now the range doesn't ever repeat. So we go from -9. That's the smallest. 0, 2, 7, 11. How many had that for the range?
Wait, is that
Okay. That's domain and range. That's the first part of this lesson. No, you don't have to change the color. Now, on this page, I want you to take a picture of this page, please. Take a picture of this page. Now take a picture. Now take a picture. Now take a picture. This is a mapping. Okay, this is a different example, and it's another way of writing out domain and range. We put them in some type of oval shape. Sometimes it's a rounded rectangle. Sometimes they're circles. But if you notice here, the x's are -4, -3, -2, 1, 2. And there's my domain in order. Okay, and over here I have 5, -4, 0, 1, -4. So -4 gets repeated, and then I have my other values. So when you construct a map, what you are to do is draw an arrow from the domain to the range. So this first one here, what we say is -4 maps to 5. So what we do is we draw an arrow from -4 to 5, just like that. Okay? That's another way of representing how the domain and range pair together. Okay? So what I want you to do is finish drawing the arrows. Okay, finish drawing the arrows for the rest of the points. Okay, -3 goes to -4. -2 goes to 0. 1 goes to 1. And 2 goes to -4. How many have that for a map? Okay? So if you're asked to create a map, that's all you're doing. You're taking the points and you're creating a graphic out of it, a visual out of it, okay? One of the things that we do with relations is determine if they are functions, okay? And in order for a relation to be a function, here's what has to be true. It's a special type of relation. No, write it down. A function is a special type of relation where each element of the domain maps to exactly one element of the range. So what that means is x only gets paired with one other y. This is another way to express that. X gets paired with one other y. I'm going to put this up here. So yeah, that's 2 ways of saying the same thing. X only goes with one y. Okay? Now, what I'm about to put on the screen is that map again. I'm going to add to this. So it's not going anywhere, so relax. Okay? So I'm going to add to this. And let me put that back. Okay? So here's the same map that we just had, minus the arrows. Let's get the arrows back in there. We do need those arrows. It's actually really important to determine if something is a function. Okay? Make sure you have arrowheads on them too, because it goes from the x to the y. So what we're going to try to figure out is whether or not this is a function. Okay? We got to figure out whether or not it's a function. Is there any x that goes to more than one place?
Yes.
Yeah.
Which one?
-4.
-4 goes to 5. -4 right here goes to 5.
-3 and 2.
-3 go to more than one place? It only goes to one place.
Number 2. No.
Does -2 go to more than one place?
No.
Okay, so look, here's the thing. I understand you're staring at this. You're seeing the 2 arrows here. But to determine if it's a function has nothing to do with the range. it has only everything to do with the x's. So each x only has one arrow coming off it. It only goes one place. Okay, because of that, this is a function. Each x gets paired with one y. Okay? Each x gets paired with one y, therefore it is a function. Here's another relation. This is the very first relation that we had, I think. Yeah, this was the first example that I gave you. Okay, I've already put at the top of it that it's not a function. Can someone explain to me why this is not a function? Maddie, what do you think?
Because the domain is
2 negative 4. So specifically, negative 4 goes with 7, but it also goes with 9. So my explanation is not a function. 4 pairs with 7 and negative 9. Okay? And that's why it's not a function. It has nothing to do with the range. It's because the x gets paired with more than one y. That makes it not a function. Okay? And on a test or quiz, when you explain why something is not a function, I want you to be very specific as to why it's not. Okay? When it is a function, you say this general statement that x only ever goes with one y. But when it's not a function, I want you to specifically cite the reason that makes it not a function. Take a picture of this screen, please. First of all, in this particular slide, we're talking about functions. We've already determined that we have functions. They're already functions. So at this point, what it says on the left in red there is for the domain, they're paired only once. So that's the part where we determine that it is a function at all. Next, what we have to do is determine what type of function it is. And what type of function it is dependent on what's going on with the range. So once we've already said, all right, each x only goes with one y, it's a function. Now we look at the range to determine what kind of function it is. I feel like what's up here is super wordy and doesn't help understand it that well. Okay? I'm going to give you a little explanation under each range that I think explains that. And so I want you to write those down, and then I'll go through and explain each one. Okay? So the blue is what determines whether it's one-to-one, onto, or both. And it could also be neither. Yeah, write what's down under in red and blue under there. Once we've determined that we have a function, we look to see how the range is being used. If all the ranges only happen one time, they only get used one time, then it's a one-to-one. I mean, they don't even have to all get used. So long as they're all used once, it's one-to-one. Okay? That's a one-to-one function. An onto function, all that means is all the range are used. Doesn't matter how many times, you just use them all. That makes it onto. And then both is literally both. All the range are used, and they are each used only once. When that happens, it's both one-to-one and onto. It is possible to have neither. So the range are used more than once, and they aren't all used. That's possible to be neither one-to-one, onto, or both. Okay? And part of what your homework's going to be is to identify which type of function it is. So again, one-to-one means each element of the range is only once. Onto, all the range gets used. Both is they all get used once and they all get used.
So then not all of them get used at the time.
I'm sorry? Let's go back to our example. Here's our example that we had. I need to put the arrows back on again. I don't know, they keep going away. Okay, there's my map again. What I want to figure out is this one-to-one, onto, both, or neither? Do all the ranges get used only once?
Yes.
Which one gets used more than once?
-4.
-4. So this can't be one-to-one. Can't be one-to-one.
It's onto.
Do they all get used?
Yes.
Yes. Therefore, This is an onto function because all the range gets used. Okay, we're almost there. The rest should not be too bad. You should have done the rest before. Okay, so here's the rest. The rest is function notation. We've been talking about functions. Let's talk about function notation. So here's evaluating functions and function notation. Now, here's what all of this means. Okay, this does not mean f times x. This means f of x, g of x, h of x. What this means is the name of the function is f, its input value is x. The name of this function is g, its input value is x. The name of this function is h, its input value is x. Okay? And in evaluating functions, usually what they do is give us a rule for f or g or h, and then they'll give you a value to substitute in that you just simplify down. Okay? That'll look something like this. So for example, I have the function f. The rule is negative 2x plus 4. They want us to evaluate f of negative 1. So you're going to take negative 1, substitute it in for x, and simplify it, and see what you get. So go ahead and do that. So here's how you should have started, okay? So I take the rule. Look at your screen, please. 2x plus 4. I substitute negative 1 in for x. That and that line up to that x right there. Okay? Then you just have to simplify that expression. Okay? Those are problems, order of operations. We did that stuff in chapter 1. So go ahead and finish that up if you haven't yet. What is this negative 2 times negative 1 equal? Positive 2. So this is 2 plus 4, which is 6. Okay? So f of negative 1 equals 6. How many had that right? Very good. Very good. All right, let's look at another one. Page. So now I've got g of x. Now we have a new rule. 7 plus 3x squared. G of 4. So now you're going to plug 4 in for x. See what you get there. Let's look. I want to take a tally of answers. Raise your hand if you have an answer. Eric, what do you have for your answer?
I got 151.
151. Dylan, what do you got?
55.
55. Anybody have a different answer than either of those two? Liv? 31. Anybody have something different than one of those three? How many have 151? Raise your hand.
How do you get 150?
Eric, are you going to raise your hand for your own answer?
I know it's wrong.
Okay. How many have 55? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-ish. 31. 3. Okay.
Oh wait, sorry.
Let's see what happens.
I wasn't my hand.
Okay, so when I plug 4 in, okay, now some of you did 3 times 4 first, which you can't do.
Wrong.
You can't do that. You got to do powers first, right?
Yes.
So this is 7 plus 3 times 16. So what do 3 times 16 is 48.
Plus 50.
The correct answer is 5.
Yay.
Okay, that's a good job. Follow your order of operations, people. Sometimes, for you guys, I think all your x's in here will be given as numbers. Occasionally, they could put a different variable in here instead of a number. And then you just plug the variable in for the letter. Okay? All right.